There's so many amazing technologies out there that are cool tech, but then they try to find a solution. We went out and we talked to contractors. There's 500,000, whatever that number shortage is of people in the field. And the answer always used to be, how do we make it better? Make the drill faster, put more vibration isolation in the rotary hammer, like incrementally make it better for the people in the field. Because at the end of the day, that's all we want to do. We want to make life better for the people in the field. And so, as we were talking to owners, as we were talking to contractors, EPC firms, the request wasn't make my person 2% more effective. It was, I have trouble finishing jobs on time because we're so short on people. We don't want 2%, 5% more productivity. How do we get 10x? So really, DeWalt wasn't actively looking to say we want to get into robotics.
On this week's show, Real Robotics with Alex Schickling from Stanley Black Decker. All right. It's good. Alex, how you doing, man?
Doing well. What's going on in your world?
Well, off the road, behind the microphone, try to get her done, get a few of these in before we head out into the second half of conference season, right, Nathan Wood?
Oh man, it's crazy. It's already almost May. It'll be May by the time this is out. So yeah, here we come. Get that mountain bike out.
We'll be in May. The mountain bike's out, trying to get her out today, start to get training. Just came off the AEC Integration Summit, so we'll talk about that one at some point. There's an episode coming, guys, so don't you worry out there. And listen, you guys know the deal. We're back on YouTube. Check us out, youtube.com/at the Contact Crew. Follow us on social media. Follow us for some cool new announcements coming. You're going to want to pay attention.
Are you trying to reach the innovators and decision makers in construction technology? Then look no further than sponsoring the Contact Crew. That's right, we're taking new advertisers. Email us at advertising@thecontactcrew.com to learn more.
All right, Alex, this is an awesome one. Like, we almost crossed paths. You were just in Brooklyn. So close, but yet so far. I have bumped into this thing. But before we get into it, let everybody know who you are and kind of how you got here.
Yeah, so I'm Alex Schickling, Director of Robotics at DeWalt. Been with the company for 7+ years, been in construction manufacturing my whole career. I'm an engineer by degree, so don't hold that against me. Love getting into the tech, getting in how do we make things better, and having a lot of fun in the industry. It's the best industry in the world, in my opinion.
So when you say you've been in it the whole time, what else have you done along the way that gets you to here?
Worked in, seismic bracing, hangars, electrical enclosures, cable tray, all sorts of different product manufacturing. Fun part's getting out in the field with people. What do they need? What's working? What's broken? DeWalt's had a lot of fun working on anchors. It seems easy. You put a screw or a wedge anchor in the ground, but long list of calculations you got to do behind it. So we support the industry there. And with the M Suite side, doing a lot in the prefab space, making sure everything's built on time, get everything out the door right. And now found my way into the robotics area.
Yeah, it's crazy because I was just in a new build out in New York City, and I'm looking up and I'm like, wow, okay, there's a lot of calculations in all those hangars, and people are like, what are you looking at? And you're like, well, okay, now that you're behind the scenes, like, this is how we used to do it, now this is how we do it. And so you've had to have seen a lot of change over the years from the beginning.
Absolutely. It's been a lot of fun. I started my career in California, so everything's super seismic braced everywhere. You lived in Texas, Illinois, been all over the country, been looked at seismic in Korea, Canada, all over the world. And it's amazing to see the changes, the advancements, all those different things that go on. And then that anchoring that it takes. It seems simple. Like I said, you put a screw in, but it's really difficult making sure it's the right one and it's fast and easy to install. So it's been an interesting trip seeing all the changes over the years.
We don't do a lot of talking about seismic, but seismic has become more and more kind of prevalent across the
Yeah.
country. It used to be just
Mhm.
California, but we're seeing it in more and more places now.
Absolutely. And it's just going to keep continuing to grow.
Yeah, and Jeff, I'm glad you grabbed me for this one because I mean I just think about the engineer in me comes out. And it's like this whole intersection of material science and data science. And as somebody who came from civil engineering, but didn't really get even close to where you are, Alex, and And this idea that in construction, we're always like, oh, construction is not manufacturing. And so when you say construction manufacturing, I'm like, wait, that's an oxymoron. I mean, maybe let's just start there of like, of all the different, career paths you've had in the world of construction and manufacturing. I guess to me, I feel like it's just because construction, every project's different, but manufacturing, you have to find certain things that are the same. Like that's that needle you're trying to pull, or that thread you're trying to pull, right? Or I guess, yeah, what's the strategy?
Yeah, absolutely. Everything is going to be different every time. But just to your point, how can you commonize things? How can you find the redundancies? How can you improve design? So, if we look at some of the things on like the M Suite side, is you start bringing these things together to say, okay, it's a different project every time. But if I can do this piece the same way, now I can make some of these ahead of time. Or if I can make that the same way, talking to some folks in the field around hangars, I mean, it used to be cut to size and then it was, different lengths. And now we see some customers putting lettuce on both sides and then they cut it in the middle in the field. Like there's so many strategies we see and, try to make sure we're adapting, working with them. But you can tell the creativity in the industry because even though every project's different, there's always things folks are pulling in to make sure, well, this part can be the same. So it's really exciting to see.
I feel like you already segued in my next one because I literally wrote over engineering versus over engineering because back in the
Yeah.
day you would over engineer because you didn't know and it was this kind of
Yeah.
like factor of safety thing. And
Was
now what I'm hearing the feedback from the field is that things get so over engineered and there's so many different options because of the preciseness that it ends up messing with the field, right? And that like simpler is better. Or you find
yeah.
that or what? Yeah, what are you saying?
Oh, absolutely. And a lot of customers we work with, a lot of contractors, what they're doing is how can we simplify it? Instead of
Yeah.
using a 3/8 rod here, half inch, or can we just standardize? So if it's a rack, it's a half inch or 5/8. Then you've got one anchor, you've got one rod, one strut profile. There's always the balance to walk. You can make everything over engineered to the nth degree, and then it's not usable in the field, or vice versa. You can thread that needle on the engineering side and then you get it into the field and it requires too much perfection. So it really is a balance. How do we find that sweet spot in the middle?
Yeah, I think you're in that like messy middle part where we're trying to figure it all out. I feel like you've been through quite a bit of that and we're seeing it, right? Like, cause we've seen some projects go way over engineered and then you're doing rework in the field before you even got it. Talk about how you've seen them people thread that needle because it's a balance, right? Because it is like there's a lot that goes on for that to get done right.
Yeah, it's been really challenging. As we're working on different products, to support the industry and doing that on the M Suite side. There's a lot of great products out there. It's spending the time because at the end of the day, that's what you need to do is figure out what went right on your project and how you can replicate that. What went wrong or what could have been done better. And just that continuous improvement mindset of each project can get a little better. Having your supers and foremen come together of, okay, what went well? Where do we want to improve? Tying it all the way back into estimation. Because a lot of times the supers learn I'm going to do these three things differently, but it's bid the same way, and then they start running into friction. So I mean, it's making sure you've got that continuous loop all the way front to back. And Nathan, I see you laughing at me over there.
I'm like, now I have to go to the human side of this stuff because you're obviously in this messy middle between having to deliver bad news to customers in the field sometimes of like, hey, like you are a little bit one off. It is a little bit too customized. Like it doesn't make sense for us. Or also, delivering news to your team or whatever that's like, hey, actually, construction is right. We're gonna have to redesign this. Which one do you end up delivering more bad news to? Like, what are the strategies on that? Like, I'd love to know. Yeah, that conflict side of it.
And there is no silver bullet. I mean, you look at things like data centers, the hyperscalers, the owners, the co-locators, they're doing a great job of trying to make it the same every time. You look at a hotel, that's, they can make those very similar each time. As you get into other project types, commercial or industrial, you've got to just find and understand this can be done better. So let's commonize this. This other stuff, it's going to be a one-off every time, and we got to make sure we're aware of that, and we're not spending the time trying to make it the same way every single time because it's just not going to work.
Yeah, and you've gotta have a lot of input on that one just given who you guys are, right? If you go back into the background, right, you are manufacturers of tools. You have a lot of experience. I wonder where or if that does that blend over where you're like, "Hey, listen, we know it's not this, right? We're manufacturing something completely different, right? It's a repeatable process, but how do you use some of that to maybe guide those that are reticent to that, "Oh, no, we can't really do it this way."
And part of the fun of that is the DeWalt brand because we manufacture thousands, millions of pieces. So even though for us, each drill is going to be the same, we learn what is the right material flow. What is the best way to get it from raw material, build it, assemble it, get it out the door. So even though each spool might be different, part of what we integrate into M Suite Fab is how can we help you optimize? So even if you're making 1,000 pieces once versus one piece 1,000 times, there's still optimal flows. There's still better ways to do things and ways you can continuously make it better.
Yeah, I mean, I've had that conversation a few times with building product manufacturers where they go, "Well, what could we really do?" And I'm like, you've been through this before. They're not gonna, we're not gonna end up putting out buildings, hyperscalers, et cetera, from a factory. But more and more of that is going to be built in a manufacturing environment and requires that rigor. It also requires the rigor of like, whoa, yeah, no, like that. No, that does not make sense. Like, we are not going to do that. And there was people who were really afraid to say that that was ever going to happen. It's like, no, that's going to happen. Like, there's things that just aren't going to happen in the factory.
It is. You can do a lot of it in the factory. You could drastically improve processes, improve safety, all those wonderful things with prefab. But at the end of the day, there's some things that just get built in the field. And what's amazing to see over time is, it used to be 20% prefab and 80% in the field. And as time's going on, it's shifting further and further. Things that we didn't think you were going to be able to prefab, all of a sudden they're showing up pre-made. It's really exciting what the industry's doing and where it's going with technology, with design, even different. How are you going to lift it up and get it in the door? There's so many pieces to take into account, and the industry is a lot of innovative people solving problems.
Here's a good one. Is there such a thing as like a logistics engineer? Like someone that's only focused on how to get the darn prefab thing into the building and like the maneuvering of it?
I
Or
don't
or
think that's a
who does that fall
title,
under?
but
Yeah,
but
yeah, who does that fall under?
contractors look at that. How
Mhm.
long can my spool be? How wide can
Yeah.
it be? How big can I that's a legitimate concern on every
Yeah.
project is I can build it. I have to have a truck that can drive it. I can't make it bigger than my flatbed or whatever size is on the road. And then I've got to get it in a door, whether it's a roll-up door, just a standard opening door. If you're doing a TI, like there's a lot of considerations.
I was just totally nerding out on this, watching a completely different thing with watching Gordon Ramsay's Netflix thing. And the biggest problem with the construction project was the lift itself. Like, the lift was not built for it. It was really funny. I was in that building in New York where they just did the build out, and somebody was marking this elevator seems kind of excessively big. And I'm like, there's a reason for that. Like, that's how they got all this stuff up there, and it's a place that changes still need this. So it's really crazy to see, like, once you see behind the curtain, what's a lot of the decision making. And, it's like, hey, you can't, if you're gonna use pods and other things, you can't put the walls up, right? It's a whole sequencing problem. So are you sequencing and getting those ahead and staying on top of it and logistics? And I mean, geez, we do need a whole logistics, like, understand where the materials are, where they're going. And again, I've always said, like, that's where you guys and other manufacturers, how to get it distributed, what you can do. And, you know, we're gonna have to change a bit because of the size, right? You make some big stuff, but these guys make really big things. So
Whatever that door looks like, whether it's a missing wall or a door, it's got to fit. And contractors do a tremendous job because they've got to balance all of it. It's amazing how they get these buildings built.
yeah, and it's all about problem solving. That's where I want to take this because this was a really cool. I got to see some previews of it. And so tell me where you are now, this director of robotics. What does that entail and what problem are you solving?
Absolutely. So I love how you frame that. What problem are we solving? Because there's so many amazing technologies out there that are cool tech, but then they try to find a solution. We went out and we talked to contractors. There's 500,000, whatever that number shortage is of people in the field. And the answer always used to be, how do we make it better? Make the drill faster, put more vibration isolation in the rotary hammer, like incrementally make it better for the people in the field. Because at the end of the day, that's all we want to do. We want to make life better for the people in the field. And so as we're talking to owners, as we're talking to contractors, EPC firms, the request wasn't make my person 2% more effective. It was, I have trouble finishing jobs on time. because we're so short on people. We don't want 2%, 5% more productivity. How do we get 10x? So really, DeWalt wasn't actively looking to say we want to get into robotics. But it's the same philosophy we've always had. We want to improve productivity, improve safety, and make projects better. So that same thinking, same mindset became this is what people need. So we went out and we said, all right, our skill set, we're great at making the same, we can make the same drill 10,000 times, very high quality, works perfect every time. We don't have a huge background in robotics. So we went out and partnered with the company, August Robotics, and said, you guys have some great tech. We love what you're doing. You're very precise, very repeatable. Let's work together. So what we did is we talked to contractors, and as they've been working on more and more data centers, this application of drilling down is just a nightmare. It takes I couldn't believe it. They spend a week on layout and then 6 to 8 weeks, depending on how seismically active the location is, drilling holes, leaning over, pushing down, hitting rebar, vibrating. It's yeah, you get it. It's a brutal task. So we didn't look at what should our robot do or what can we make the robot do. We looked at, hey, what is needed? And overwhelmingly, we are told we hate drilling down. So we partnered up, we found a solution, and we've launched it. At this point, we've drilled over 200,000 holes on data centers. We've been in the market less than 9 months with our early access program, and it's been going extremely well. It's very exciting.
I mean, this was so cool because you didn't we call it solutioneering you're like, "Ooh, yeah, we got a cool thing. We're gonna solve something. Let's go find it." But you went looking for a problem and then like, "Well, wait a minute. What are we really good at though?" And you are really good at drills. You're really good at high quality parts, repeatable that this industry trusts, right? So there was a person holding that thing before. I was freaking out because 2 things that when we first met, you made me do that I can't stop doing now is A, looking at anybody who's doing that on concrete by themselves, like by hand, and just realizing like, ow, that hurts. It is so rough on the body, so rough on if you get it wrong, right? That's the other thing is like, we're human. We mark the spot, but we go a little bit. And what I didn't realize, Alex, was especially in the data center world, because I get to tour them once in a while and see them. Everything is bolted to the floor. It's all bolted down. It's all slabbed out. And you said it, and I'm like, oh, that poor team. Oh my gosh. So awesome problem. So explain how it solves that problem, kind of what it does.
Yeah. So what we tried to do is we looked at what is required. It's got to be very accurate. It's got to go fast because it needs to meet the timeline, and it needs to be repeatable because it's not just a single data center popping up. They're all over the country, all over the world. So
They're building data centers places?
yeah, I know. I was shocked too. Who would have thought?
Nathan, we should get an episode out on that.
What?
There you go.
How's things happen outside of America?
I know. It was a really cool opportunity. So, August already had a lot of the technology developed. So we partnered with them, put our rotary hammer, our dust extractor. When we look at safety, there's multiple points. We don't want anybody breathing in silica dust. We don't want anybody's arms vibrating. We don't want any sprains or strains. So we're able to take one solution where you basically are on your iPad, you click go. The robots know where they are in the building. They go point to point, so you don't have to lay out and then come back. And it just blows through the data hall real fast. I mean, we had one project where I want to say there were 29,000 holes in one half of the data center, and we had that done in less than 16 days. Just let the robot go, and the amount of hours that took off of humans of just vibrating and shaking. But the best part was the project was being run, the robots were actually being run by steam fitters. So the people were still there working. They were still out there doing their thing, but much safer.
Yeah, and that scope was there, and let's talk about that too, because this was a unique piece. Is well, 2 things. One, silica dust. People do not talk enough about it. I do have a masonry background, and we saw a lot of the studies, etc. And it's also dangerous to those other folks in the environment. So I can imagine that it's a bit safer and more comfortable if you're working on half there's other stuff going on the other half, and you're not worried as much about ventilation, about wearing, N95s, et cetera, what you have to wear to cover yourself from that. So provides a safer concurrent environment, which is like a productivity increase on its own.
And it also helps too. Part of what DeWalt brings to the table is we've got OSHA Table 1 compliant dust extractors, rotary hammers, all these systems that are designed to work together. So where August is great with robotics, they didn't have to try to invent a new rotary hammer dust extractor. We more or less use all off-the-shelf parts, combine them in a new way, and save thousands of hours of hard work on the body.
Yeah, and I mean, obviously, we don't have to talk about the physical, but the repetitive nature of that sends people home smoked. It really does. I mean, if you watched anybody, there's just no two ways about it. And talk a little bit about how, because it is the steam fitters are getting, and I asked you about this. I'm like, where was this scope in the beginning anyway? So whose scope are you taking, quote unquote, and where is it? What's the outcome been?
Yeah, so that's the fun part. We haven't taken any scope. We are working with them in partnership. So on some projects we've been on, the mechanical contractor scope of work is to drill out the holes. Others it's been the GC self-performing. We're talking with some companies and it's actually the steel erectors who drill the holes out. So it's a broad variety of scope of who's got it. We're coming in as a partner saying, "Hey, we're going to work with you. We'll bring the robots. Your crew is still going to be involved." And the best part is because there's so much of a gap in that labor shortage, nobody's going home, nobody's getting laid off. They're getting to do these skilled tasks. I mean, the amount of skill a contractor has is incredible. So for somebody who's that skilled to be drilling holes in the ground all day, it's not the best use of their time. If we can do that with them, let the robots do the work, they're now using their skill on these other items. So they're focused on the skilled tasks and letting the robot do the physically demanding task that doesn't add the same amount of value and need the same skill as a lot of these other tasks that get done to build these data centers.
Yeah. So in theory, the contractor that takes advantage of the accuracy of where the holes go should be in charge of that scope. It's not always that way, but yeah.
Nothing's ever perfect, and it makes it easier across the board too, because when all your holes are the right place, the anchor installation comes easier because you don't have one sitting at 8 degrees at an angle, one under drilled, one over drilled. So now all your rods are making a little wave. It's all the same. It's all simple. So when they drop the base plate on it, literally is just dropping a base plate on it. It's that simple. So it makes several steps of the process easier.
Yeah, that's crazy, and it just increases that accuracy, which is rework, which is what we don't want, and issues. It it's interesting too because we talked about it, like, it was also kind of a hot potato scope because it's hard on the crews, and there's so much to do that isn't that, so it's kinda like, you're a hot potato, you take it." And now, Nathan, I think to your point, as people learn more about what you guys can do and how it can be done. I don't want to say they're going to be fighting over it, but they're going to be having that conversation, Nathan, of like, hey, this is important to my scope. And if I can have, if it's important to the steam fitters, if I can have a couple of my steam fitters out there early doing this process, imagine all the other things they can do for site prep, for understanding the location, getting in and out, logistics we just talked about. There is we try to do this virtually all the time. There is no freaking way to understand the nuances of getting onto one of these hyperscalers, especially because there's never just one, right? Like it's a freaking campus, and you got to find your way around, and you got to know, hey, they CAS this and move the parking lot like every 2 days. This is all valuable information that these steam fitters can be bringing back and understanding and getting to know a project beforehand.
A- a- Absolutely. I mean, the value that can be added and bringing those people in is incredible. And you talk about the how it's working. What we saw before is it was a lot of apprentices who were doing the drilling. The rookies, the junior people. Can you imagine you sign up, you want to learn to be a mechanical contractor, a steam fitter, whatever group you want to be a part of, and you get to spend 10 hours a day, 6 days a week, 220 some days a year drilling holes in concrete. Like it's rough.
And you made a mistake, so 6 months later, you got totally grilled or
Yeah.
whatever for the
It
mistake you
turns out
made.
everything was shifted 2 inches to the left, so you get to do it again.
So now you have PTSD.
Yeah,
Or
right?
there's some person standing over you going, "Look at the wave you created," because you're not
Yep.
standardized, and we wonder why
Yeah.
we chase them out. I thought
Oh,
it was
yeah.
bad when we handed them paper and pen to fill out forms when they got there. They might be like, "Oh, no, I'll do the
I'll
forms,
take that
guys.
paper and
I
pen,
don't
yeah.
I'm
I
not
remember
doing
when I
that
was
thing."
responsible for concrete layout drawings. I should not
Yeah.
have been responsible for concrete layout drawings. Someone with ADHD should not be responsible for very intricate, very specific
Oh.
layout drawings.
Talk a little bit about now they're on site working with the machines. How is this all going? Like, how many people do we have? Like, what does it look like in action?
Yeah, it's a lot of fun. So we typically have, depending on the scale of the project, anywhere from 4 to 8 robots. The goal is to just blow through, get it done. So we typically, if there's 4 robots, we'll have 2 people from the contractor who are running them. 8 robots, we'll have 3 people. And really what they're doing is we call it the pit stop, right? If I've got a carbide, a battery, and a vacuum, they all wear over time. So we come in, we do the setup, we use control points on the ground. The whole system locates itself. Really cool the technology August developed. They can actually like daisy chain points. So whether you're in a specific area or corner to corner, 800 feet apart, you're always within 1/8 of an inch. So they've got that plus or minus eighth across the whole board. So once you've located it, you just hit go. The robots know, okay, here's all my point locations. Here's my diameter. Here's my depth. And it knows, all right, I've got a 3/4 inch carbide. I'm going to just go drill every 3/4 inch hole I can. And then the person who's running it sitting there with a tablet, it'll say, hey, your vacuum's 30% full. Your battery is 80% charged and your carbide looks good. Okay, great. I can go do something else. I can sit and watch them, like whatever that person's assigned to do. And then as the bag fills, as the carbide wears, the battery gets low, the tablet notifies them. They just hit pause, go swap it out. Under 3 minutes, they're hitting go again, and the robot's back in action. So it's designed to be mostly autonomous, but it absolutely has those people there working with it to make sure that you're getting your vacuum bags changed and all those basics to make sure everything keeps running smoothly.
I love that pit stop idea and the iPad idea because think about that exact scenario where you showed up as the apprentice and we handed you the tools to drill it yourself and you're not very psyched. But now we've got, someone experienced on the team and say 2 apprentices there. They've got iPads. They're, the pit crew for these machines and that the journeyman, the experienced person can be talking to them, can be explaining what we're gonna be doing, can be looking over that site, and yeah, it might not sound awesome. What do? I get rid of the bags and I, replace the bits and I change the battery. Until you say to a killer robot that's drilling holes on the data center that runs the AI or whatever it might be, all of a sudden you've connected this job to something important, powerful, and that's what we know is construction's underutilized talent. Show off what we do.
Yeah, it's incredible what's going on in construction today with all the different robots, software's making things better and streamlining, prefab versus on-site. I mean, there are so many incredible things. I think we're doing ourselves a disservice in how it's promoted. Like we should be at colleges showing robots, showing some of these amazing things. I mean, I love construction. It's such a fun career. It's so many amazing people you get to work with. Like getting to work with a robot all day, it's pretty awesome.
And yes, and I do want to go back because without over sensationalizing this amazing, awesome tech and everything that I know Jeff loves to do, we have to go back to our problem, right? Because where you started, Alex, was not just that we don't have enough people, because that wasn't the problem you started with. It started with we don't finish projects fast enough. Why don't we finish projects fast enough? Because we don't have enough people. Why don't we have enough people? Because they get hurt, because they get sick. You did that whole 5 whys analysis, and I mean, kudos to DeWalt and SBD because shoot, this whole anchors to rockets, all this design thinking that we do at the AEC Integration Summit, and what Jeff and I have been passed around through construction came from a DeWalt workshop. Back I think probably before you started, there was like 2017, where I learned the anchors to rockets, exercise. I was like, holy cow, this is what we need. So again, like the fact that you get to play with all these cool robots only started with your very savvy ability to do that, identify the challenge, do the root cause analysis, make sure that the solution is attacking that lowest root cause anchor, and then address the accuracy and the reliability and all those things that still would have been a problem with the apprentice too, right? Like those root causes are totally exclusive of this. So just kudos to that. And for those listening, that like that's really what's important, is that what problem is it solving? And then here's all the other cool things.
One of my favorite things you just said, there's a concern people not only get hurt, like, an active injury, if they start when they're 20, how do they have a 45-year career? One of the biggest like indicators we're on the right path and we're doing the right thing. I had a contractor tell me, he's like, I used to be the one drilling. Now I'm working with you on the robot. He said, I didn't know if I was going to be able to have a full career in construction because of the amount of wear and tear on my body. And he's like, now I could run this robot till I'm 90. I mean, it's not hard. It's easy to run. It's safe. It takes all the stress and strain off me. Let's beat the robot to death. That's okay. But he's genuinely excited. Like, this is adding longevity to my career, and I'm excited about that. I was just like, whoa. It blew me away because you think of active injury, something falling, something hitting you, but just that day-to-day repetition on the body is rough.
In biking, we call it burning matches, and you can't burn matches where you don't need them. Hang on to them, keep them in the tank for there are things that are gonna be look, we're not getting rid of Chad Pearson likes to talk about this, like, we're not getting rid of the physical nature of the environment. It's never gonna be completely like, I just don't believe you're ever gonna have completely robotic things putting everything together and no humans doing dangerous manual things, hard things to do. We're getting better and better and doing less and less. It's still gonna be there. But why don't we give those people longer careers, keep them safer, keep them fresher for those? That's where, this robotics trend, it's funny as it's starting to really, I think it like, of course, they all go through the hype cycles and everything. We've seen a million of the different things and some really good hits and a lot of misses. We've seen a ton of misses along the way. There's a lot that aren't here. That's the other cool part is you didn't just say, "Okay, so we found that and we went into the lab and we designed a robot." You went, "Wait a minute, we know what we're good at." And I think that's an important distinction because there are others out there building, say, robotics that don't have your skills. So this partnership, this coming together is something I would like to see promoted because it brings two great skills together.
It would take DeWalt a long time to become an expert at robotics, and that's not a negative. Anytime you do something new, there's a learning curve. So instead of why would we go through a learning curve when there's somebody we can partner with who's got the same philosophies as us? I mean, you mentioned to your point, robots won't do everything, and that's a good thing. We need people in the field. We need to have people on site. The good thing is let's focus the robots on the tasks that are the most dangerous, the most repetitive. Let's let humans use their creativity. I mean, people are really smart. You get out there and talk to those contractors, man, the way they figure stuff out is incredible. So if giving them the better tools, keeping them safer, it benefits everybody.
Yeah, it really does. And it focuses their time again. I can't say this enough, just being somebody who's I don't know if this is a recent just realization of staying close to the work really drives just I don't wanna call it the moment of just catching things, but the the getting comfortable in the job itself, you can create better flow, you can create things, so this, again, gives those creative people time to look for problems ahead, to, understand how things are gonna go. It's awesome. Now I'm wondering, and, maybe we'll let you get in this seat a little bit, 'cause, again, we all said, like, it's not gonna be this big job site full of robots, but what are some of the things you think could be, like, super valuable in the future? It doesn't have to be things you're working on, just where can people start thinking about this?
Truthfully, I'm not even the person to answer that. What we have done is we fundamentally, like, we came up with this robot because we went out to the field. We talked to contractors, we talked to owners, we talked to people high up in the construction company. What jobs are the hardest? Whether it's hard because it's just physically demanding, it's hard because it's incredibly difficult to do. There are so many hard, repeatable tasks. I think that's where a big miss is. You talk about partnerships. It's, hey, we've got this cool widget, it can do this. Well, if the contractors love doing whatever this is, you're going to have an uphill battle trying to get it adopted. That's why we fundamentally looked at it as, person in the field, what do you need? Owner, does this make sense to you? Construction company, not just individual, does this make sense to you? So we've got a lot of ideas. There's a lot of different aspects that can be improved. But at the end of the day, it's about making life better for the people. What tasks do they need and should be taken off their plate so they can focus on the right thing?
High dust, highly repetitive,
Yeah.
yeah, unsafe locations. So yeah, I mean, there are a ton of those.
Yeah, heavyweight, high vibration, you're talking repetitive overhead work. There's a lot of things that can be improved. And we're really excited to partner with the contractors, not just try to launch the next thing.
Yeah, anything that you work at odd angles, anything like that can be very, very dangerous. And I don't think we've even scratched the surface with where this is going to go. But you need these things to do this and really drive an improvement.
Yeah, I mean, I guess maybe just to finish up on that whole how do we learn more from the field? How do we gather from them? Like, because I think I face a lot of folks in the field that are just kind of that naysayer. They've been there in a million years and they're just going to say no to everything. But I feel like maybe there's like a personality type, or have you found there's certain folks that are really good for that will be receptive to questions, but also give you the naysay when required. Maybe we'll wrap that up. Go ahead.
I love the naysayer. Tell me why it's dumb. Tell me why it's a terrible idea. I'm going to learn from anything regardless. So if this is a terrible idea because it can't be that accurate, okay, I now know the first thing I need to do is make it accurate enough. Oh, it won't work because of X, Y, and Z. Now my spec, if we're going to take this forward, needs to do X, Y, Z. And then talk to the person who loves robots. Oh yeah, this would be great application. This would be great. And they're throwing out, 57 things they'd love to see. So I actually love the naysayer. They're the person who's the most practical, the most realistic, and frankly, they've seen a lot of technologies come in that were going to be their silver bullet magic solution and solve every problem they ever had, and see them continually struggle. I love the naysayers. They're the most fun to work with because when you get that person to say, "Okay, that maybe this will work," it's like, "All right, now we know where we're going." When the super positive person says, "Hey, this is great," it's like, you wanted this to be successful. Let's see.
This is awesome because this is for our founders out there and the others out there who are like, well, geez, I had that small group of people and they just loved it and it was just awesome. And well, I don't know why it's not working. And I was like, they were really excited and they made workarounds for everything. And that's kudos to them for doing it because they're creative, but it's not scalable and nobody told you no. It's not true validation. That you're right. That validation, and this was an old Google thing when Google started Google X. Their first KPI wasn't what does success look like, it's what does failure look like. They wanted to drive the earliest failures to figure out if something just cut bait and go because it's not worth it, or hey, we're just barking up the wrong tree. We got to know that sooner. We got our technology committee together and it went great. So how many people on your technology committee hate technology? Probably not a good idea. You actually need them. Like we need a balance, the contrarian in our lives, Nathan, right?
So don't preach to the choir. Okay, got it.
Oh, preach to the choir.
Yeah, I love the naysayer, man. Once you get them on board, it's just a night and day. Like, okay, this is actually, we got something here.
Well,
Well
and they're the
said.
ones who everybody expects to turn around and go like, I kicked that robot. And they turn around, they're like, I love this thing.
Yeah.
And everybody goes, wait a second. There has to be something to this.
Oh,
They
yeah.
don't
yeah.
like, they don't
They
like
don't like
anything.
They're your
anything.
best spokesperson, yeah, by
Yep.
far when you can get them.
Yep.
We had one of those moments where the person who used to be drilling was working with us on a site, click and run, changing bags. And so one of the owner's representatives came up and asked him, they're like, hey, we recognize this is new. Like you're going from you doing the work to now you're running the robot that does the work. What are your thoughts on the robot taking this task from you? And his exact word, well, I'm not going to use his exact words because some 4-letter words in there, but essentially his message was, it can keep it. I don't want it back. Like and he was one of the people saying a robot can't do this. It's going to be too hard. It's too difficult. But he's like, don't give it back to me.
I love it. There's your mic drop moment. Alex, I know you guys are in the early stages. Like you said, it's only been out a few months. Where can anybody who's excited to learn more go learn more, find out about you, find out about the robot?
Absolutely. Email, we've got robotics.sales@dewalt.com. So reach out. I'll be the one answering you. We've posted all over LinkedIn, August Robotics has a part of their website dedicated to the drilling robots, so the information's readily available. And Jeff put my email address at in the chat, and I'd love to reach out, geek out on robots, or talk about your projects. I'm down. Let's do it.
That's awesome. We're definitely going to do it. And shout out to August Robotics. I've been watching them for a really long time. They fantastic organization, shows up for the industry, creating some really unique things. So cool to see this partnership happening and something new. So Nathan, it's always good to catch up with you, buddy.
I love nerding out about problems and root causes and intersection of material science and robotics and data science. This was fun, man. Thank you, Alex.
Oh, I love this. We'll do it all day, man. As long as you guys want to let me.
Well, we will let you, and hopefully
you're
see
definitely
you
invited to
again
the summit
somewhere
next year.
soon.
Yeah, we'll see you at the AEC
Yes.
Integration Summit next year for sure.
Let me know. We'll be there with the robots.
And thank you for tuning in today to geek out for our interview with Alex Schickling. To read all our news stories, to learn more about our guests, and to listen to this show, visit thecontactcrew.com. This is the Contact Crew signing out. Until next time, enjoy the ride and geek out.